Okay, welcome back. This is 1.6, transformations of functions, and in particular, what we're worried about is graphs. Okay, so 1.6, transformations of functions, and we're dealing with graphs. So what they're going to do is kind of build a vocabulary of graphs, and then we're going to define some operations on these graphs. And it'll allow you to graph common graphs very quickly. You won't have to always default to your calculator. Okay, so let's take a look. Graphs of functions. So hopefully as you go through the math classes, you kind of build a vocabulary of particular graphs. So here's one that we all know and love, is just a horizontal line, right? Like y equals b. Okay. And then obviously the diagonal is another one. Okay. So as you go through, you can make a little book of them, you know. There's some people that there was one website online that was like this guy had an encyclopedia of functions, not just functions, but equations in general, which is pretty cool. But some of it is pretty complicated. So, I don't know. We're not there yet. Absolute value function looks like a V. And where we have the parabola. Right. Y equals x squared. The square root function. Okay. So y equals square root of x. Cubics kind of look like this. So that's y equals x cubed. I apologize if you can't read this one over here. Let me write it. Square root of x. Okay. What else? Cube root function, I guess. Okay, so cube roots kind of looks like this. So that would be y equals cube root of x. 3 in there. There it goes. Okay. So you'll add into these, you know, if you take trig, then you'll have cosine and sine and the tangent. And later on, we'll get the exponential and the logarithm. And then to graph them, I mean, you'll have the picture in your head, but to graph other ones, you could just do these like transformations. And you'll be able to produce like an infinite number of graphs, I guess. So anyways, the first kind of transformation you could do to these guys are the vertical shifts. The first most elementary type, right? So how will this look? You'll have some function from above there, and then you'll either add in some value, c, and that will shift it up. So c is assumed to be positive in these problems. So c is greater than 0. So a shift up. Or y equals f of x minus c will create a shift down. Okay, so let's look at an example. And this, I checked the book. It is consistent with the book. So this is number 54. But if you're watching in the future, it may have changed if we, changed additions. G of x equals x squared minus 1. So you quickly can draw that if you know what x squared looks like. And we do know what x squared looks like, right? So x squared looks like this. And you can always add in some extra points, like 1, 1 is on x squared, 0, 0 is on x squared. So to get g of x equals x squared minus 1, you just shift everything down by 1. So I maybe put that in red. So I'm going to shift everything down 1 unit. And I'll have my new graph right here. Okay. So it becomes real easy to graph things. And that was a terrible graph, but Yeah, I think you get the idea. It should be the exact same graph, just moved down by one place, by one tick mark, basically. Right. Let's look at one more. So another example, g of x equals the cube root of x plus 2. Right. So what I'm doing is let's get some points on the cube root of x, right? So the cube root of x, x, and then the cube root of x. If you put in -1, you'll get out -1. If you put in 0, you get a 0. 1, cube root of 1 is 1. So those 3 points are on the graph. Right? So -1, 0, and 1. And it kind of has this S-type shape to it. And that's, it shouldn't level off. It should just keep on kind of going. Oh, jeez. Silly marker thing. Okay, so it should look like this. And then if you add 2, that's just going to shift everything up by 2. So 1, 2 will kind of be, let's put it in blue this time. So 2, and then 1, 1, 2, we'll put that guy there. And then this other guy will kind of go here. I mean, you don't need to put in extra points, but it helps me. As I get older, I'm not as good as drawing. Okay, but it will just be the same graph moved up. Hopefully you get the point. Okay. Another way to think of it is basically you're just taking the original x comma y coordinate and adding 2 to the y. So in this case, if you start with x comma y, then you're going to change it to x comma y plus 2, or y plus c. Okay. So all the y coordinates will go up. And then for the second guy, if you have x comma y, it'll change into x comma y minus c. Right? All the y coordinates will get shifted up. Down by 2. So you can see that in particular on this graph, this point here is -1, -1, and then if you add 2 to the second coordinate, well, what do you get? Well, you get up here then -1 comma -1 plus 2, and of course -1 plus 2, so -1 comma is 1. Okay, so that coordinate is just that. Okay. So it's another way of thinking about it, and sometimes that helps in the later problems, or even when you're doing WebAssign, because a lot of them are multiple choice. You just pick A, B, C, or D. Okay. Anyways, let's look at the next type of shift, which is the horizontal shift. Horizontal shift. Okay. So the main difference is you're kind of adding something inside the function. So if you have x plus c, that will shift it. And people usually get this and screw this up. It doesn't shift it right. It actually shifts it left. Okay? And then if you subtract c, and we're assuming again that c is greater than 0, this will shift it to the right. Okay. In particular, if you have a coordinate x comma y, if you have plus c, it'll take all of the x values and just shift them to the right by c, or sorry, the other way. Right? You're shifting left, so it'll be x minus c. So it's a little confusing, you know. Comma y, and then if you're shifting right, you're taking all those x coordinates and you're adding in something. I know it's confusing. Okay, so horizontal, let's take a look at problem 20 here. And they give us this kind of weird fabricated graph, and we have to shift it. Okay, so the coordinates on it, 1, 2, 3, need about 5 tick marks. In the negative x direction, 5 tick marks in the positive x direction. I want to go up by 2 and down by 2. Okay, and then the points, we have -4, 0, and then -2, -2, -2, and then 0, 0, and then 2, 2, and then 4, 0. So it looks like this. Okay, so let's go to the work. What are we doing? We want to graph f of x plus 1, okay, given f of x. So maybe let's put it in red. So x plus 1 means we take the given coordinate. So for example, this coordinate here is at -4, 0. We're going to subtract the x coordinate by 1. Okay, so that'd be -4 minus 1 minus 0, so -5. Okay, so the new point would be over here. And literally all it's doing is just shifting every point 1 to the left. So I don't recommend sitting there and subtracting all the coordinate points. That would just be insane. Okay. Use common sense, folks. And there's our new graph. Okay. You could do horizontal and vertical shifts together. You want to do them in the order of horizontal first and then vertical, although it probably won't matter at this point. But there is kind of an order of operations. So you can kind of think of the shifting of these graphs as kind of arithmetic, but using pictures instead of numbers, right? So here we go. Horizontal plus vertical shifts together. And let's look at problem 86 maybe from the book. I just call it an example. Okay, so they want h of x equals absolute value x plus 3 minus 2. So the original thing, if you look back at all of our kind of typical graphs, is what? What was the original graph? And it's an absolute value, right? It's y equals absolute value of x. So that's kind of what I'll start with, is just graphing y equals absolute value of x. If you need to, you can graph some points to help you out. It's not necessary, but so let's take a look at the original. So -1, 2, 1, 2, 0, 0, +1, 2, 2. So here is our original guy. Okay, and so what do we want to do? We want to, on the inside, you're going left by 3. Okay, so we're going, maybe I should mark that down, left 3. And then on the outside, it looks like you're going to have to go down 2. Okay. So the inside, that +3 is the left by 3, and then the -2 is the up-down movement. So that, in this case, is going down. Okay, so you can take every point, and you can do that. 1, 2, 3, so you need some extra tick marks. Let's put it in red. So I'm going left 3, and then down 2, 1, 2. So the first point ends up here. Let's put some extra tick marks on the y-axis. So the origin point at 0, 0 is going to go left 3, 1, 2, 3, and then down 2, 1, 2. So that'll end up right here. And then finally, the 2, 2 will go left 1, 2, 3, and then down 2 right here. Okay, and you can almost see where those points need to end up. I'm not sure about where it intersects, but here it is. Ugh. Okay. Okay, so we're going to be putting all these different shifts that we learned together and doing a whole bunch of them to one particular graph. Okay, the next kind of transformation are reflections. Okay, so this is where we're kind of rotating about an axis, or you can think of it as kind of like copying and pasting. Okay, so let's take a look. Reflections. And the first kind, you're putting a negative excuse me, on the outside of the function. And what does that do? That's going to do a x-axis rotation. So I'll draw it like this, and then remind you it's x-axis reflection, or rotation if you'd rather. And then if you have the negative somehow on the inside, it's going to do a y-axis rotation. Okay, so you're going to twirl it around the y-axis. Okay. The result of this stuff is if you begin with xy, it's going to change that into x comma negative y. And then for y-axis rotation, if you begin with x comma y, it'll transform it into negative x comma y. Okay. Okay, so let's take a look at an example. And again, we have this this one from above, where we have 1, 2, 3, 4, 4, 1, 2, 1, 2, and negative 4, 0, negative 2, negative 2, 0, 0, 2, 2, and then 4, 0 is the original. And they want us to draw f of negative x. Okay, so that's a rotation about the y-axis. So if you have the point, let's say 2 comma 2, it'll turn into 2 comma negative 2. Okay, or sorry, negative 2 comma 2. Right. Okay, so let's do that. So this point I just was playing around with will end up right here. So negative 2, 2. 0, 0 will stay where it is. 4, 0 will end up at negative 4, 0, so that'll be right here. Negative 2 will be at positive 2, negative 2, so that'll be right there. And negative 4, 0 will end up at 4, 0. So the end result will be this thing right here. Okay. Okay. Let's take a look at stretches and shrinks. Okay. And the first type are the vertical types. And I get my marker working here. Here it goes. So first vertical, stretch, shrink. And so how does this work? You're going to go y equals c times f of x, and then there's two cases. If c is greater than 1, it's going to be a vertical stretch. You think of that as amplitude, how high and how low it goes. In particular, if you have a point x comma y, it will turn it into a point x comma c times y. Okay. Then if you have c is like a fraction, so c in between 0 and 1, then it'll be a vertical smush or shrink. Okay. And so if you begin with x comma y, it'll turn it into x comma, well, c times y again, but now c value will be some sort of fraction, so the y value will be decreased by a factor of c. Okay, okay, so let's take a look at a problem, and we'll be using that weird sort of graph from before. We want to graph 1/2 f of x. Okay, so this will be a vertical smush. And let's draw our graph. 1, 2, 3, 4, 4, 2, 1, 2, and it's this thing from before. So I'm getting good at drawing this. Okay, so what is it doing? It's multiplying the y coordinate by a factor. Okay, so at negative 2, this point, the new coordinate is going to be negative 2 comma negative 1. Right, so let me put it in red right here. for the point 4, negative 4, 0, if you multiply y, which is 0, by 1/2, it's just going to be 0 again, so it's still in the same place. Same for 0, 0, right? Okay, so you can see it's smushing it down. Then at 0, so originally this guy was at, 2, 2. If you multiply this y coordinate by 2, you get 1. Okay, so the new point will be dropped down to here. Put that in red. Okay. And then finally, this guy's height won't change because you're just multiplying 0 by 1/2. Okay. The horizontal stretch shrink case, then let's take a look at that. And trig, this will be the period. Okay. So how do we set this up? So y equals f of c times x. So you're putting the c on the inside, and it's kind of a reverse scenario. So when c is in between 0 and 1, that's actually when you have the stretch. So you look before, when c was in between 0 and 1, you have a shrink. But now it's going to be the stretch. Okay. And in particular, it's going to change the x coordinate. So if you started with x comma y, it's going to change x by a factor of 1 over c, okay, in this case. So this will end up being 1 over c times x comma y. Okay. And then if you have y equals f of cx, where c is now greater than 1, again, it'll change the point xy into 1 all over cx comma y. Okay. Okay. Let's try some of these, and we have a different example this time. Different weirdly shaped graph. Let's see if I can draw it all in one picture here. So I need 4, 0, 1, 2, 3, 4. And eventually I'm going to have to go out to 8. So let me just tag 8 on there. 7, 8. And I'm going to have to go up 4, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay, so the original graph, I'll put it in white. It's negative 4, 0, negative 2, 4, 0, 0, and 2, negative 2, so 2, negative 2, and then 4, 0, 2, 3, 4, 0. And it's like a upside down parabola. And then it has sort of a corner, it's like a cusp down there, and it's straight lines. Okay, so they want two things. The first one I'll put in red. They want f of 2x. Okay, so what that's going to do is take all the x coordinates and cut them by 1/2. Okay. So for instance, if I have a negative 4, 0 here, the new coordinate is going to be negative 2, 0. So it'll be right here. And then if you have negative 2, 4, which is the next point in line, okay, so negative 2, 4, the new coordinate will be negative 1, 4. Right? So negative 1, 4 right here. And then 0, 0 will just stay 0, 0. So you see how it's kind of smushing the graph against the y-axis. And then 2, negative 2 will become 1, negative 2. And then 4, 0 will become 2, 0. So it smushes it. And then they also want you to graph f of 1/2 x. And what will that do? Well, that will stretch it, right, by a factor of 2. So if you have negative 4, 0, your new point will be negative 8, 0. If you have negative 2, 4, your new point will be negative 4, 4. And if you have 0, 0, your new point will be 0, 0. So, okay, so it's stretching the thing out. Okay. If you have 2, negative 2, it'll become 4, negative 2. If you have 4, 0, it'll become 8, 0. Okay. And again, it stretches it horizontally. Okay, so it's a pretty cool picture. Okay, we want to put all of these together now, so we'll have sequences of transformations, and there is an order to it. Okay, sequences of transformations. So just like, please excuse my dear Aunt Sally, there's a sequence of transformations here. So it's just your basic language. How do I communicate to somebody else that I mean that the graph is here, not here, right? So first you're going to do your horizontal shifts. Secondly, you do your stretch shrinks. Thirdly, you're going to do your reflections. And then fourthly, you do your verticals. Okay, so let's take a look at some examples. We'll do f of x equals x minus 1 squared plus 2. So the original graph is x squared. We can maybe do a little table for that. So of course, negative 1, 1, 0, 0, 1, 1. Okay. So negative 1, 1, 0, 0, and 1, 1 is the original. And what is it telling us to do? So the minus 1 is telling us to go right 1. And we have to do that first because that's the horizontal. And then the plus 2 is telling me to go up 2. And I do that second. Okay, so right 1 and then up 2. So right 1 is going to move all of this junk over to here. And then up 2 is, let's put that in red, up 2. So I need some more tick marks on my axis. I'll put them in white. 1, 2. Okay. So now my blue points will go up 2. So 1, 2 will go here. 1, 2 will go here. And then 1, 2 will go here. And that'll be my new graph. Okay, let's try another. So example, example, h of x equals square root of negative x plus 1. Okay, so the original graph is square root of x. So if you need some points, you can get a couple going here. So 0, 0, 1, 1, 4, 2. So let's take a look at the original. 0, 0 is right here, 1, 1, and then 1, 2, 3, 4. Probably 1, 2, 3, 4. Let's just put 5 in there. Be careful. Put 1, 2 down here. So 4, 2. 1, 2, 3, 4, 2 is right here. So here's our square root function. And then what do I have? So the plus 1 is going to shift it to the left by 1, and then the negative in front of the x is going to be a y-axis rotation. Okay, so I have to do the horizontal shift first. Okay, so you can even write down, okay, there's a right shift 1, and then a y-axis rotation, or reflection, I guess we're calling it. Okay, so go right 1. So all these guys will go over 1, and we kind of have this figure here in the dashed blue. And then we want to rotate that around the y-axis. Okay, so this kind of rotation. So all the x-coordinates will be negated. They'll be made negative. So if you have negative 1, 0, that'll become 1, 0. Okay. pen the work here. If you have 0, 1, that will still be 0, 1, so it'll be there. If you have 1, 2, 3, 2, that will now be negative 3, 2. So 1, 2, 3, negative 2. And that will be our final picture. Okay. Maybe one more. And then we'll call it quits. There's a lot of homework in this one. Another example then. H of x equals negative x minus 2 cubed, so it's a cube function. So let's try x and x cubed, get a picture. So negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. So that kind of gives us a good place to start. So I need about 3 tick marks, I guess. Okay, so 0, 0, negative 1, 1, 1, 1, 1, and then it kind of has this shape to it, like a curvy type thingamajig. Okay, so order of operations. On the inside, you can see there's a horizontal shift, so we want to go right 2. And then on the outside of the function, there's that negative. So that is your x-axis rotation, or reflection. You got to do that second. Okay. Okay. Did I do it wrong upstairs on that last one? So no, right is first, and then, okay, we're good. Okay, so let's try this. First, all the points will go right by 2. So 1, 2, 1, 2, 1, 2. That'll be kind of the first move. It's not a bad idea to kind of record your movements on the page as you go along. And then finally, negative rotation about the, whoops, I got to go right by 2. Sorry, I went left. It's going to be impossible to erase that. Oh, jeez. Sorry. Okay, that wasn't so bad. Oh, jeez, there it goes. Oh, no. Sorry. Okay, so you got to go right 2. Sorry. So 1, 2, 1, 2, 1, 2. So there's our first graph. And then all the y coordinates are made negative when you do an x-axis rotation. So if you have 1 negative 1, it'll become 1 positive 1. Okay. 0, 0 will remain at 0, 0. And then 1, 2, 3, 1 will become 3 negative 1. Okay. So that'll be your x-axis rotation about this. Okay, so your end graph, and I'm not sure where it hits the x-axis, but it looks something like this. Okay, so if you're if you're a visual learner, I think this is right up your alley. There's a lot of cool pictures. You could, I can imagine my art majors making a little sketchbook you could take to the coffee house and impress everybody. Look at this cool stuff I'm doing in math. Okay, a lot of homework, so get in there as soon as possible, and we'll see you next time.